Hello Year 6 and welcome to Week 5 Maths Day 4. So today's Thursday the 21st of May. We've got some subtracting fractions for you to do today. Before we start we're going to have a little warm up. So looking at these fractions in front of you, they come in pairs. We would like you to make those following pairs so they have the same denominator. We want them to have the lowest common denominator. So pause the video and see if you can find the lowest common denominator for the following pairs. Okay, so let's see if you've got the same lowest common denominators as we did. Okay, so you should be nicely warmed up now. Let's go and have a look at our problem solving one. Now, just the same as yesterday, you're going to have some very similar problem solving to do. And you can choose between core or a slightly more challenging one. The choice is yours, and we'll talk about that in more detail at the end. So have a little look at this and see what you notice about the problem that you've been asked to solve. Okay, now the way I solved this is I started by at this end. I started looking here because actually this is all the numbers here. There's nothing missed out, there's nothing I need to guess or fill in or calculate. It's all there for me. So I started by turning that mixed number into an improper fraction. Have a go at doing that now. Okay, so we've got a 3 as our whole number. That means that we've got 6/6 3 times. So what does that mean we have as a fraction? So 3 times 6/6 is 18/6. But that isn't all we've got. We've not just got the whole number. There's a fraction, isn't there? 3/6. So 3/6 and 18/6 added together, what does that give you? Yeah, 21/6. Now I'm going to keep the number as 21/6 for the rest of this calculation. So I'm now going to think about that number 21/6. So 21/6 is quite a big number, isn't it? Now remember that we're subtracting. That makes me think carefully about the numbers that we might have in the calculation. So I've now highlighted this number. It's got a missing whole number, but the fraction is a sixth. That makes me think that that's going to be quite a high number if when I subtract something from it, the answer is still 21/6. So I'm going to start thinking about what that number could be. Now, I decided to make some notes, and you'll probably want to do this too. So let's have a look at the notes that I made. Now, as you can see, along the side of the page, I've made notes about the possible whole numbers it could be, and I've turned it into an improper fraction to help me calculate. So let's have a look at those in a bit more detail. So the top one. 1 is my whole number, so that's 6/6. Add the 1/6 from the fraction, that gives me 7/6. Same for the next one. 2 is my whole number, so 2 times 6 is 12. Then I add the 1/6 from the fraction, that gives me 13. I kept going, so 3 times 6 is 18. Add the 1 from the 6th fraction, that gives me 19. So as you can see, I worked all the way through and I kept going until I had 6 as my whole number. I was working systematically, do you see? Now that's enough for me to start with. It might be that my answer's there. So I'm going to have a look now at my second number in the calculation. What do you notice about that? Okay, now I know this is going to be quite a small number, because remember what we said about 21/6, that's quite high, isn't it? So I'm going to be taking a small number away from it. So I think my whole number will just be 1. So my possibilities is 1 1/3 or 1 2/3. I can't have 3/3, remember, because that will be another whole number for me, and that will take my whole number to 2. And I want to keep it quite a low number. Now what do you notice about that? Do you notice that we've got thirds as a denominator? We can't have thirds as a denominator because we won't be able to calculate with it. So can you now please pause the video, and I would like you to change 1 1/3 and 1 2/3 into sixths. So I would like the denominator to be sixth. Do you remember why we need the denominator as sixths? That's right, because if we're calculating, we need the denominators to be the same. So pause it, and on the next slide, we'll see if we've got the same numbers. So here we are with the arrow returned again to help us. So 1 1/3, I changed that into sixths by multiplying the numerator and the denominator by 2 to give me 6. So that gave me 1 2/6. And here again, 1 2/3 I converted by doubling the numerator and the denominator to give me 1 4/6. Now I wanted to turn these mixed numbers into improper fractions. So let's look at the top one. In the whole number there are 6 6, and in the fraction there's 2 6. That's 8 6 altogether. And in this one the whole number again is 1, so that's 6 6, and added on the fraction 4 6 is 10 6. Okay, so now look back at our calculation. We're looking for two fractions that have a difference of 21. I'd like you to pause the video now and have a look through our first column of 6 and our second column, which has only got 2 6s in at the moment. Can you see a pair there that have a difference of 21? You spot these two? So 5 1/6 is equal to 31 6, and 1 4/6 is the same as 10 6. And if you subtract 10 6 from 31 6, you get an answer of 21 6. Did you get those? Okay, good. Now, we need to put them back in the answer. Now, as you can see on the calculation on the right, I've filled in the first number. Now, although we were looking at 31 6 and then taking away 10 6 from that, the question doesn't ask us for that, does it? It doesn't ask us for the improper fraction. So I've kept on my notes and I've looked back at them, and I can see that the mixed number is 5 1/6. So I've just filled that in. So now let's have a look at the second part of the calculation. It's 1 4/6, isn't it? We don't want the answer in 6, though, do we? So can you quickly change 4 6 into thirds? Did you get 2/3? Yeah. Although that was our answer, there are other values that you could have had. So if you did get a different answer, it doesn't matter. As long as the calculation worked out, that could be correct. So here's our problem solving, and you're going to be doing a problem very similar to this. So let's have a think about how we would solve this. Pause the video, look at what you're meant to do, and see if there's anything you notice about the numbers. Okay, so you can see you're meant to use the cards, and you can use the cards more than once to put them in the places in the fractions to make the calculation correct. And what did you notice? Did you notice that the answer in the denominator answer is 12? What does that mean about the two fractions that make up the question? Yeah, they must be factors of 12. So can you see we've already got a 4. What other number could we have in there? Yeah, I decided it was going to be a 3. So where does that leave us now? What else did you notice? Did you notice that there are mixed numbers for each of the calculations? So 3 and something thirds, subtract 1 and something quarter, gives you 2 whole and something twelfths. Okay. Now we want to know what's going to go into this number here. Now if I know that I want the denominator to be 12, what am I going to have to do to that number? And if I know for this one here, if the denominator is 4, what am I going to have to multiply that number by to make it 12? So I'm going to have to multiply everything in this fraction by 4, because 3 times 4 is 12. And everything in this fraction I'm going to have to multiply by 3, because 3 times 4 is 12. Okay, what else could I do then? I'm going to have to try and find out what that numerator is. Let's try some cards now. Say, for example, I wanted to put the 5 there. I want to put the 4 here. Let's have a go with these. So let's work them out. 5 times 4 is 20. And 4 times 3 is 12. Could it be those? Did you have a think about if it was going to be those? If it were 5/3, that's an improper fraction, isn't it? And as we've already got a mixed number, we've got a whole number of 3, I would expect the numerator to be less than 3. So let's try a different number. So I've picked some smaller cards this time. I'm going to have a go with these. Now, do you see with our whole numbers, do you see the first whole number is a 3? If I take the next whole number away from it, which is 1, it gives me 2, doesn't it? So the whole numbers are already correct. We just need to worry about the fractions. So I'm just going to think about the fractions now. So 2 times 4 gives me 8, and 3 times 3 is 9. It's not going to be that, is it? Because the first fraction that I have gives me a smaller number than the second fraction. If I take it away, I'm going to get a negative number, and there's no negative number here, so it can't be that. So let's try some different numbers. Why don't you have a go, see what you come up with. Okay, so I swap that 3 for a 1. That will give me a smaller number, won't it? So 2 times 4 is 8, and 1 times 3, yep, that's 3. So then I'm going to think 8 and subtract 3. If the answer is one of those cards, then that will work. Yep, we can all see the answer there, 5/12. So you will have a similar problem to do when you get to your work. So just think about the way that we worked. If you want to cut out the cards, you can. You can make little cards out of paper at home. Okay, so here's finally our reasoning. So have a look at the reasoning problem. I want you to pause the video and see if you can see what you need to do for this one. Okay, so what did you notice about the calculation? Did you notice that it's mixed numbers again? I don't mind these mixed numbers because if you have a look, 3 subtract 1 equals 2. We can leave the whole numbers as they are and just look at the fractions. Okay, so did you notice anything about the fractions? They all have the denominator of 12 apart from the first one, but that's quite easy to sort out, isn't it? How do we turn quarters into twelfths? That's right, we multiply by 3, don't we? So let's just do that. So now it should be a simple case of carrying out the calculation. So the whole numbers are fine, aren't they? 3 subtract 1 equals 2. So now let's check the fractions. Are they correct? So 9/12 take away 1/12. Does it equal 2/12? No. So we can see that Molly is incorrect. I wonder if you can think of a good reasoning answer. Can you explain to us how we know that she's incorrect? What has she done wrong? So here's my answer. Have a read of my answer and see if you came up with a similar reasoning. So I don't think Molly made 3/4 9/12. She didn't make the denominators the same before she carried out the calculation. So I think she did the 3, the numerator as it was, subtract 1 to give us 2. So Molly should really have made the denominators the same. I'm sure we won't be making the same mistakes as that. Okay, so you're going to go to Term 5, Week 5, Day 4 in the Maths section, and there's going to be a copy of the work you've been asked to do there. Now, as yesterday, there will be a core sheet for you to do, or there will be a slightly more challenging sheet for you to do. You choose which one you do, don't do both, and they will follow a similar pattern to the work we've just looked at on the slides. Okay, good luck.